Hello class, welcome to Basic Electronics class. Hello class. So today we are going to read the most important topic of OPAMP, that is inverting OPAMP. Okay, so the OPAMP has wide application, and the most widely used application of OPAMP is inverting OPAMP. So why the name is inverting OPAMP? Since I have told you in the previous lecture that an OPAMP has two input terminals. This is negative and this is plus. This is called as inverting terminal. This is called as non-inverting terminal. So when the input voltage is given to the inverting terminal and the non-inverting terminal is grounded, then it is called as inverting OPAMP. And another thing is, if suppose you are giving any input signal to the OPAMP, okay, so what will happen if the output will be amplified and if it will be having 180-degree phase shift, so that is your inverting OPAMP. Okay, so it has wide application in many areas. It is basically used in oscillators. It is also used in DC amplifiers. So it is a very important topic. So now let us see the parameters which you can see in the diagram. So this is a feedback loop which is going to the inverting terminal. Okay, this is the input voltage Vi. We have two resistance Ra and Rf. Ra is the input resistance, Rf is the feedback resistance. Okay, now this is the node from where the feedback loop is dividing. Okay, so now let us see the derivation of the inverting OPAMP in more detail. So let us start with KCL. So by applying KCL, so from this point there is a division. So what is the current in this loop? It is IA. So IA equal to IX plus IF. So let us write it down. So IA equals to IX plus IF. Okay. Now if you remember, I have told you that in an ideal OPAMP, the internal input resistance, which is over here, is very high, or internal input impedance is very high. So in that case, this IX is 0. So in an ideal OPAMP, this IX is 0. Okay, so IX equals to 0 for an ideal OPAMP. Okay, so we will apply it over here. So IA will be equal to IF. Okay, now what is the value of IA? So IA equals to Vi minus Va divided by Ra. So let us write it down. Vi minus Va by Ra. And what is the value of IF? It is Va minus V0 by RF. So okay, now a very important thing which I am going to tell you here is, in an ideal OPAMP, this voltage and this voltage is equal. Okay, means whatever be the value of this voltage, that is your non-inverting terminal voltage, this voltage, the same will be the value at this node. Okay, so Va equal to Vb for an ideal OPAMP, and in this case, what is the value of Vb? Vb is grounded, so it will be 0. So I will put this value in this equation. So what it will be? Vi minus 0 equals to Ra divided by Ra equals to 0 minus V0 divided by Rf. Okay, so this concept is very important and it is called as virtual ground concept. Okay, so it is very important. You have to remember this because the same concept will be used further also. So now see what I have got. Vi minus 0 divided by Ra equals to 0 minus V0 divided by Rf. Okay, So again it can be written as Vi divided by Ra equals to minus V0 divided by Rf. Okay, or V0 equals to Rf divided by Ra into Vi. A minus sign will be here. Okay, so this is the value of V0. Now what is the gain of an amplifier? So if I will write V0 by Vi equals to minus Rf by Ra, and this is equals to gain or equals to AV, voltage gain. Okay, so this is how you will get the derivation of the inverting op-amp, and this is the gain of the inverting op-amp. So in this gain you can see I am getting a negative sign, and this negative sign indicates that there is a phase change of 180 degree. That is why my signal is coming in the inverted direction. So in the next lecture we will discuss the derivation of the non-inverting op-amp. Thank you for watching the video. If you have any suggestions or any doubts, you can put it in the comment line.